Who suffered the last case of smallpox? Introducing Janet Parker. Janet was born in England in 1938. She worked as a photographer at a medical school. In 1978, there was a big accident at the school's lab. Janet caught smallpox from the lab, and sadly, she couldn't get better. She passed away on September 11th, 1978, the same year she contracted it. This was a big deal because smallpox was a very dangerous disease that had almost disappeared. But Janet's death made people realize that even though it was almost gone, smallpox was still a big threat. It made scientists and doctors think harder about how to keep labs safe from dangerous germs. Janet Parker's story reminds us why we need to be careful with diseases that can make us sick. Her passing serves as a lesson for everyone about the importance of safety and being cautious, especially when dealing with deadly diseases. So now we're going to talk about the background of smallpox. Smallpox is caused by the variola virus and has been historically a dangerous disease. It inflicted death and suffering worldwide. It's highly contagious and spreads through respiratory droplets. It has a mortality rate of up to 30%, and it's incredibly a large public health threat. The virus weakens the body's immune system, presenting with symptoms like fever, headache, backache, and vomiting, followed by a severe rash that affects the face, limbs, hands, and feet. Survivors often bear permanent scars from the disease's effects. However, there is a silver lining. Smallpox stands as the first disease eradicated globally, thanks to a concerted effort to vaccinate populations worldwide. This success shows the cooperation in combating the most daunting diseases. The study of smallpox has yielded significant advancements in medicine, particularly in vaccine development. The pioneering smallpox vaccine, developed by Edward Jenner, not only contributed to the disease's eradication, but it also paved the way for preventing numerous other illnesses. Despite its eradication, smallpox's legacy as a potent weapon of war still persists. Mark Palin wrote a book called Days of Smallpox. It vividly recounts the escape of the virus from that laboratory in 1978. It highlights the crucial need for safety measures and handling dangerous pathogens to be altered. Palin's narrative serves as a reminder for the importance of prioritizing public safety and scientific research and the ongoing vigilance that's needed to prevent similar incidents like this in the future. Next, we're going to be talking about the basics, more into who Janet Parker really was, how did she specifically contract this strain of smallpox, and at what rate did her illness progress. As we talked about earlier, she died the same year she contracted it. She was born May 11th, 1938, in Birmingham, England, and decided to dedicate her career to medical photography at the University Medical School nearby. Her role involved capturing images to aid in medical research and education, although she didn't work directly in the lab. Tragically, in 1978, a laboratory technician accidentally released the smallpox virus into the air, which Janet then contracted. Despite being diagnosed initially with chickenpox, Janet contracted smallpox. Smallpox was thought to be globally eradicated since 1977, so this came as a shock to many people. Her illness progressed rapidly and was marked by symptoms like the fever and the typical rash smallpox presents with. Despite many medical efforts, Janet's condition deteriorated very quickly. On September 11th, 1978, Janet died due to smallpox. Her death shook the medical community because people thought that smallpox had been completely eradicated. It also made people aware that biosafety measures were not up to date, not only at the University of Birmingham, but also research institutions worldwide. The tragic event of her death showed people that biosafety protocols needed more vigilance in handling dangerous pathogens. Janet's legacy serves as a reminder to the devastating consequences that can arise from lapses in biosafety practices. Parker also had a big impact on public health. Understanding the importance of safety measures in labs is super crucial for preventing outbreaks of disease. Take Janet's case. He worked as a medical photographer at the university, but still caught smallpox in 1978, even though she never directly handled the virus. This shows how important it is to have strict safety rules in labs to stop diseases from spreading accidentally. Her story reminds us how risky lab work can be and why we need to follow safety rules carefully. Using proper equipment and following safety protocols are key to stopping diseases from spreading. When Janet got sick, investigators traced her movements and found everyone she might have contacted and exposed the virus to. This helped to stop the disease from spreading any further, and it shows how important it is to track diseases to stop them from spreading. Also, Janet's case happened just after the world had eradicated smallpox with the vaccine. Even though she wasn't vaccinated, her story reminds us how important vaccines are from stopping diseases from coming back. Vaccines have helped us control so many dangerous diseases, which shows how important they are for prevent. They are an important prevention measure for keeping us healthy. So, how does this case, Janet Parker's case, connect to other disciplines? Let's first look at how environmental factors affected Janet's health. The University of Birmingham Medical School didn't have strong safety measures in place. This led Janet to being exposed to smallpox, even though she didn't directly work with it. It shows how important it is to have those strict safety rules in labs to protect lab workers and the community from infectious diseases. Now let's talk about how Janet's situation might have been influenced by socioeconomic factors. Janet worked as a photographer, so she was around the lab where the smallpox virus got out. But her access to healthcare and vaccines could have been limited because of her socioeconomic status. This means she might not have been able to get the care she needed to prevent or even treat her illness when she contracted it. This highlights the need to address social factors like access to healthcare and education to make sure everyone has a fair chance at staying healthy. By improving access to resources like vaccines and other opportunities, we can help reduce health disparities and make sure that everyone has the support they need to stay safe and well. Edward Jenner created the smallpox vaccine, which helped stop the spread of the deadly disease. This vaccine is an example of how medicines can teach our bodies to fight off infections. I took a class called Basic Pharmaceutics, which is the study of how medicines work, and we learned about how vaccines are made and then given to people. Jenner's vaccine was made by using a weakened version of the smallpox virus, so it couldn't make people sick. It teaches our body how to fight the real virus if we ever come in contact with it. Pharmaceutics also teaches us how to store and give vaccines properly so they work well. Vaccines need to be kept at the right temperature to stay effective when introduced to the body. So, learning about vaccines like Jenner's helps us understand how medicine can keep us healthy by teaching our bodies to defend against certain diseases. So, to wrap this up, we learned about Janet Parker and her case, smallpox as a disease, the spread of it and how she contracted it, and its impact on the healthcare system. The eradication of smallpox is a huge accomplishment, and it shows how people all over the world can work together to beat a disease. But there's still a debate whether we should get rid of or keep the smallpox virus in samples. Janet Parker's sad story reminds us why we need to be careful when studying infectious diseases. If we decide to destroy the virus samples, it might seem safer, but we'll also lose important resources for future research. It's important for us to talk openly about this and make sure we prioritize safety and global health in our decisions. The recent decision by the Purebright Institute to get rid of its last rinderpest stocks has started discussions about what to do with the remaining smallpox samples, which was the first virus we got rid of. Keeping the samples could help us develop treatments and vaccines if smallpox ever did come back, but getting rid of them would reduce the risk of accidents or bioterrorism. Even though we've made progress in developing medicines and tests for smallpox, we still haven't decided what to do about the samples. We need to have clear rules about when it's okay to destroy these disease samples, including smallpox. Thinking about Janet's story reminds us of the big challenges in keeping people safe from diseases. It's important to be really careful in labs, watch out for disease spreading, and make sure everyone gets vaccinated. Stopping diseases is not easy, but if we work together and learn from what happened, we can make our communities healthier and safer. Thank you for watching this educational video on Janet Parker, the last and final case of smallpox. Some additional resources include peer-reviewed journal articles published by the NIH, as well as a riveting article written by The Lancet on Rinderpest, smallpox, and the imperative of destruction. Articles published by the CDC also serve as great sources for more information on smallpox and Janet Parker. Thank you and have a great day.